Okay, hear me out. Don't copy first. Okay, first thing, differentiation of logarithmic function, we are only zooming in on one kind. Last year, you know logarithm, you also know common logarithm is log. Am I right? Natural logarithm will be common logarithm is log. LG is log to base 10. Am I right? What is natural logarithm? Log. Correct? Okay, but for differentiation, are we ready? For differentiation, we are only zooming in on natural logarithmic function. So you don't have to do differentiation for log, at least not at Sec 4 level, only for log. But can you change log term to long term? You can. Change of base. Learn before? Yeah, of course, forget already, more than a year ago. Now, I'm going to give you the general form. If I want to differentiate a term like this, very simple, this is ln, the term inside ln will be ax, am I right? What you need to tell yourself, if I want to differentiate this term, the term inside the bracket, write at the denominator. After that, differentiate the term in the bracket and put it at the numerator. So what's the final answer here? 1 over x. That's it. I make it a bit more complicated again. What if I have ax plus b? What do I do to the bracket term if I want to differentiate this logarithmic function, which is natural logarithm? Same thing, look at the bracket term, what is it? Ax plus b. Put it where? Put it where? Below at the denominator. After that, what do we do? Differentiate this term, what do I get? A. Where do I put it? On top at the numerator. Finish already. I'm done with the topic. It's that easy. Happy, right? I saw some smiley face already for one. Trust me, logarithm and exponential, the differentiation is very easy. But shit happens. Why? They will make it confusing for you, but it's definitely not so confusing. Trust me. You just need to simplify before you differentiate. It's always the same thing. You need to simplify before you differentiate. Alright? Now, turn to page 410. We are going to go through a series of different kind of differentiation for long terms. Alright? A few of them. Practice now 5. 1A, no brainer. Differentiate the following with respect to x. I believe you can tell me the answer immediately. If I want to differentiate ln bracket of 5x plus 2. What do I put at the denominator? 5x plus 2. What do I put at the numerator? 5. We are done. Happy, right? Well, that is the simplest question. Jason, are you okay?
Yeah.
1B. Okay, get a little bit more difficult, but it's still not difficult. Ln of sine 4x. Still not very difficult, but slightly only. Differentiate long term, right? What is inside the bracket term inside here? Sine 4x. Okay, so tell me, Ashwa, what do you put at the denominator? Sine 4x. After that, you differentiate what? Sine 4x again. And put it at the numerator. So, Izan, what do you get? 4 cosine 4x. Anyone has a different answer? Yes. Some of you give me this answer, I already give you full mark. But if you give me this answer, even better. Because cosine over sine will give you a cotangent. Am I right? But it's not necessary. Like I say, this answer is good enough. Okay? Still easier? Okay. Getting more difficult really. I'm very certain some of you take a look at 1C. Your first reaction is, huh? What the hell is this? Magic. Okay, look at this one now. Starting from C all the way to E, these are all star questions. Star meaning sure come out. Sure. This side come out, please lah. So easy. Only one question or two questions will come out in the whole entire exam. You expect me to give you this one and this one? Not possible. Okay? But tell you, this is not difficult. We just have to simplify because Mr. Liu already said you only need to differentiate ln of something like this. If it looks like this, your job is to simplify until it looks like this. Yes. Can you tell me, cube root of 3 can be written as? Power 1/3. Thank you. I'm still not happy because at the start of the lesson, I never say anything with a power. But you learned last year in your logarithm. Whenever there is a power term for logarithmic function, this power term can be written as a x cubed. Thank you. Whenever there is a power term for logarithm, how can we write the power term? Yes, you can bring down the power term as a constant value. Can you remember this particular law of logarithm last year? Okay? So like I said, Mr. Liu never teach you how to differentiate got power up there one. This power will always be 1. So what can we do with this power 1/3? Bring it down. And the rest is super easy. Now we can differentiate. This is a constant value. Do you need to worry when you differentiate constant? What do we always do? Just continue writing. Please, you want to use product rule also can. This one 1/3 is 1 term, log is 1 term, no need. You differentiate 1/3, you get 0. Am I right? So no need. Constant value, always keep it. Now, differentiate this one. Ln of this bracket term. What do you put at the denominator? X cubed plus 2x. What do you put at the numerator? 3x squared plus 2. And this is the final answer. Easy? Tell yourself, it's actually very easy, provided the general form, the given equation, it must be simplified to give you something like this. Okay? Why you got log? Wow, good question. That's why I say all these are star questions. So remember, this is the first law of logarithm you need to remember. Anything with logarithm, there is a power term, you can bring it in front as a constant value. Now we already move on to the next one already. 1D. Wow, another difficult one. Yes, I heard that. What was it? Change of? How do we do the change of base? R or A. Like change of base, I'm going to show you. Regardless whether it's logarithm or natural logarithm, which is ln itself, change of base. if this is given, tell yourself, okay, what base do you want now? Huh? The one B lah, got A and B here, the one B lah. I already say got A and B here, don't want B, this like don't want A also lah. C. The moment you want to change to a different base, tell yourself, please write the new base first. The main term, put on top. The base term, put below. Finish. Same thing. But Mr. Liu, I don't want log to base C. Our job is I want log. Write log no. What do you put on top? The main term. What do you put below? The base term. And we can do that as well. Agree? So the second one, change of base. Very good. As we do this, we are going to recap what you did last year. Over the March holidays, there will be more work for you all to do. So now, Zhenyu, how to change this before we can differentiate? Log. Very good. Now, can you try to do this yourself? I'll give you 30 seconds. Differentiate lah. You don't know, man? And let me tell you, I only need 4 seconds. I give you 30, Not that I belittle you, because I think you all need to copy or you all need to think. It's not very worried, you keep saying about my tire. Nobody can see the trick. I can tell you it's very straightforward, but can I give you a hint? I can further simplify the y. Please don't go and use quotient rule. Cancel away the log. Wow, the log can cancel like that one. You cannot cancel. The reason why I write this way is because it's change of base. This is not B over A. You don't cancel the log, there is a bracket here. You are applying log to B and applying log to A. Okay, look here. Nobody, I walk around, nobody saw the trick, but some of you get the correct answer, not that you saw the trick. Okay, you do it the other way around. Now, what did Mr. Liu say? You only differentiate long terms like this. Do you differentiate long terms with denominator? No. Don't have. But what is ln 7? Is it a number or is it an unknown? It's a number, right? If it's a number, means it must be a constant. So, to make my job easier, why don't I write it this way? It's a number. You get a hint? Now can I give you 4 seconds? All agree? Simplify. The job is try to simplify. 4 seconds. Now 4 seconds can do, right? Jason, right? 4 seconds, how to do? You also call Jason today, Yes. Wait lah. Last period, I joined the class. So in the class, thank you. Jason, 4 seconds. Oh! Jason, do I need to differentiate this one? What is this? A number. When it's a number, you just continue to write the number. Don't need to calculate. You calculate, you get a decimal number. It looks very ugly. Now, Jason, can you tell me what's inside? What's at the denominator? Then what's on top? Then answer already, oh? Is it 4 seconds? 4 seconds can finish already, provided you simplify the expression. Okay? I'm telling you all the tricks now today. Last one. Okay, the last one. This is the popular one. I must say the last one is the popular one. Last one. 怎么办? Simplify. Yes, I heard simplify. Brandon, how to simplify? Okay. Very good. Ryan already said we can use another log. I'm going to write the log first. Log A divided by log B. Log A over B. It will be log A minus log B. You all learned this last year? Log as a single term for division, you can write two different log terms subtraction. Similarly, log A times B is the same as log A plus log B. So now, Brandon, how do I rewrite this one? Ln x minus ln square root of x squared plus 2. Do you like this square root of x squared plus 2? Square root can be written as half. Power half can also be written as. Thank you. Then the whole question suddenly becomes so easy. Correct? And this is the most difficult question in this unit. This is the most difficult. Okay, I already tell you already, this is the most difficult. Means confirm will come out. Or confirm. Think of how to differentiate. 1 over x minus half 2x over x squared. Okay, but I'm sorry to tell you, this cannot be the final answer. Why? Not about times 8, you can simplify. 2 and 2 can reduce to lowest term. Am I right? 2 divided by 2 is 1. So this is your final answer. Okay?